Hello everyone, welcome to Pre-Algebra with Miss Betsy. This video today is going to consist of simply two examples from our skill check for section 7.4 in our text. Our text is the first edition of Pre-Algebra for Christian Schools published by Bob Jones University Press. It's not directly compatible section number wise with the second edition, but you can still gain a lot of information from this. I'm in section 7.4, which is entitled Problem Solving, Writing Equations, and we've been working with rational numbers today, working with rational numbers this week. And I'm headed out of town in just a bit, so I'm going to just jump right into this and illustrate a couple of problems for you. So Father, thank you for this year that you have given to us as we have a chance to pause and think back on it as we get to the end of December. Thank you for your presence in our lives and for the way that you love us and care for us. Help us to be diligent with our studies and help us to remain focused on you in Jesus' name, amen. Okay, for quite a long time now I'm going to be able to use my joke book from Connor. So the lame joke for today is, can you tell me what it is that you would be served for breakfast when you eat with a centipede? Well, they're going to serve you, they're going to serve you pancakes and legs for breakfast. So, we've spent a lot of time working with word problems and learning to translate from English into algebra. And one of the key things that we learned is what English words do we have that translate directly into types of operations. And of is one that we learned always indicates multiplication. And we learned that when we multiply something by a fraction, if we're going to multiply a fraction by a variable and we want to be able to solve that equation, we learned that in order to keep our equation in balance, you perform one operation on one side of the equation, you have to perform the same operation on the other side of the equation, and we use we use inverse operations to solve those equations. So if we multiply something, if we've multiplied the variable, we're going to divide both sides of that equation by the number that we've multiplied by. It's a little bit different when we're multiplying using a fraction. We can see here that we've multiplied x by 3/4. So following that inverse operation method of solving problems, we would divide both sides of the equation by 3/4. And while this is a perfectly legitimate operation to perform, it's a little bit awkward looking and tends to make our brains go tilt and say, what in the world am I supposed to do? So we learned that with rational numbers, which are things that look like fractions to us, dividing by a fraction is the same as multiplying by the reciprocal. And the reciprocal is when you take that fraction and you stand it on its head. So rather than try and divide this equation by 3/4, we're going to multiply both sides by the reciprocal. And then you see that you have common factors that cancel. 4 divided by 4 is 1. 3 have a common factor of 3, so you have x on the left-hand side of the equation, and 3 divided by 3 is 1. So you have solved this equation, and you said that x is equal to 4, and you're going to virtually always use the method of multiplying by the reciprocal when you simplify equations that involve rational numbers. So, having said that and having a reminder here that when we see the English word of that we're trying to translate into math, that of means to multiply by. So, skill check number 1 on page 228. Oh, this is funny. A math teacher discovered that 5/8 of his students made A's on the semester exam. He counted a total of 15 students who made A's. How many students were in his class? And the instructions ask us to do two things. They say first write an equation, and then secondly solve that equation. So let's see what we want to do here. Okay, a math teacher discovered his students made A's. How many students made A's? Okay, well let's say let X equal the number of students who made A's. That makes sense, doesn't it? We want to figure out how many students made A's. That's what our variable is. The number of students who made A's. Now, we're going to look at our problem again and see what equation can we come up with. Well, he says 5/8 of the students made A's. He counted a total of 15 students made A's. So how many students made A's? 5/8 of the students made A's. And how many students made A's? 15 students made A's. So you wouldn't have to write this on your paper, but I'm showing you what I'm thinking. 5/8 of the students made A's. Okay? Could even just put, they made A's. Let's fill in some more of this information. What are we using for students? We're using X. What does of mean? Of means to multiply by. So 5/8 of the students made A's. How many made A's? 15. Now, I know some of you have difficulty because there are different ways, so many different ways that you can indicate multiplication. This right here says 5/8 times X. Use that parentheses because we don't want to put 5/8 XX because that's confusing. You could have said 5/8 and then put your dot, but we've learned that when you bump up a number against the parentheses, that just means multiplication. You can simply erase those parentheses, and this is how you're always going to be indicating 5/8 times a variable. There's nothing in between it. Now we have a variable multiplied by the fractions. We're simply going to multiply both sides of this equation by the reciprocal of this variable, which is 8/5. So we multiply the left side by 8/5, and we multiply the right side by 8/5. And I want you to notice that what I've done here on the right-hand side is I've structured this, or I've done my writing very carefully here, so it looks like the 15 is in the numerator and the 5 is in the denominator. That just makes it easier for us to remember that 15 can actually be written as a rational number divided by 1, but we don't need to do that. But that helps us remember that we have a common factor of 5 in the numerator and in the denominator here. We have our common factor of 8. Leaves us 1. Our common factor of 5 leaves us 1. And this is why we love multiplying by the reciprocal. Because when you multiply a fraction by its reciprocal, you always get 1. Which is exactly what we wish to find. We wish to find what X is, or the number of students who made A's. Now in our numerator and our denominator, we have a common factor of 5 here. 15 divided by 5 is 3. 5 divided by 5 is 1. We multiply numerators, multiply denominators, and you end up with 24 divided by 1, or 24 students. And that is the solution to our problem. So the math teacher had a much larger class than I do. I'm not quite sure how he had a class that big. He must have been a college professor. But 24 of the students in his class made A's. Okay? Now let's go ahead and look at problem number 2 in the skill check. And this one is going to go even much more quickly because I did a little bit of review for you right there at the beginning. Let's look at problem 2 on page 229. The offering received at the Sunday morning service was 2.5 times the offering received at the Sunday evening service. If the offering on Sunday morning totaled $350, what was the total amount of the offering for both services? Okay, now that right there tells you have a very small congregation that's giving. Okay, so the first thing that we want to do is we want to come up and define a variable and say, what's our unknown? What is it that we're looking for? Well, we're looking for, offering. We're looking for the total amount of the offering of the evening service. So, we're going to say let X equal the amount of offering, or the amount of the evening service offering. Okay, now let's see what we can find to read here. This has a little bit more information in it, so don't let yourself get psyched out. Read it slowly. The amount of the offering was 2.5 times. Okay, the amount of the morning offering was 2.5 times the offering of the evening service. So if the offering on the Sunday morning totaled $350, what was the total amount of the offering for both services? So when you look at this, you're looking for two quantities that you can come up with that are equal. One of them has to be that number here. So what is the amount, that $350? That is the amount of money that was received in the Sunday morning offering. So we're going to have something on Sunday morning offering is the actual numerical amount that we're given. So what can we use for our variable here when our variable is talking about Sunday evening, but we have an amount here for Sunday morning? Well, our first sentence tells us the offering received at the Sunday morning service. The offering received at the Sunday morning service was 2.5 times the amount received at the evening. So if we take the evening amount and we multiply that by 2.5 times, then that gives us the Sunday morning amount. Now, we have a mixed number. Remember I said you're not going to multiply by mixed numbers. You're going to convert to an improper fraction. 5/2, when you multiply that by a variable, just as written, 5/2 x, is equal to the Sunday morning offering, or the evening offering multiplied by 2.5 times gives us the morning offering, which is $350. And now, to solve this equation where we have the variable multiplied by an improper fraction, we're going to multiply both sides by the reciprocal. 2/5. When you multiply a number by its reciprocal, you end up with 1. So on the left-hand side of the equation, we simply have that our 2's and our 5's cancel, respectively. We have x is equal to, well, we can say 2 times 350 is 700 divided by 5, or we can cancel immediately this common factor of 5. 35 divided by 5 is 7. 350 divided by 5 is 70. 5 divided by 5 is 1. You can do this division out to the right-hand side of your problem. 70 times 2 is $140, and this is the amount of the evening offering, I believe. Okay, interesting. See, I didn't look. What is the evening offering? Okay, this is the evening offering, and I just went right ahead and said this was our answer, didn't I? There's quite a lot going on in this problem. Let's go back and look at the bottom here and see what it is we're trying to find. We're trying to find what was the total amount of the offering for both services. How do you find the total amount? Well, you take morning plus evening. So the total amount of the morning offering was $350. The total amount of the evening offering was $140. The total offering for Sunday was $490. Okay? So they asked us to find the total amount of the offering. They gave us information about the evening offering, information about the morning offering. We used that together to come up with a numerical amount for the evening offering. We added those two together to come up with $490. Now, let me say to you again, that problem there was a little bit involved. Some of you won't have any difficulty with it at all. Some of you will have to chew on it for a while and then you'll finally figure it out. Some of you might go, I do not have a clue how to do this. The more that you practice word problems, the easier it's going to get for you. However, they're not a hill to die on. I want you to put forth a good, solid amount of effort on these. I want you to try these diligently and be very careful to do your best job on them. But if you can't get them, don't worry about it. Move on. There are plenty of other things in algebra that you're going to learn that if you get tripped up on the word problems, it's okay. Those are things that the more practice you have, the better you get at them. And you saw I was in a hurry. I told you I'm headed out of town, and I was going to stop with $140 when that's not even what they asked for. I had to combine the morning and the evening to come up with the total amount of the offering, which is what they were actually asking for. Anyway, y'all have a great New Year's, and I'll see you in January.